Close your eyes for a moment and imagine standing on a beach. The waves roll in, the horizon stretches endlessly, and the ocean looks calm, flat, and almost familiar. But here's the truth most people never really grasp. What you're seeing is just the thinnest surface layer of a world so deep, so extreme, and so alien that it makes outer space look surprisingly accessible. The ocean is not just deep. It is unimaginably deep, in ways that challenge human intuition, technology, and even our understanding of life itself. To put things in perspective, the average depth of the ocean is about 3,700 meters. That's over 12,000 feet. If you dropped Mount Everest into the ocean, its peak would still be more than a mile underwater. And that's just the average. Certain parts plunge far beyond that, descending into trenches so deep that sunlight has never reached them in Earth's entire history. When we look at the ocean from above, it feels vast in width. But the real mystery lies vertically. Humans are surface dwellers. We evolved to think in terms of length and width, not depth. That's why it's so hard to mentally process what it means to go down, not just hundreds, but thousands of meters into crushing darkness. Let's start at the surface, where sunlight still penetrates. This upper layer, known as the sunlit zone, extends only about 200 meters down. That's it. Everything beyond that exists in permanent twilight or total darkness. Nearly all ocean life we're familiar with, colorful fish, coral reefs, dolphins, whales, exists in this thin slice of the sea. Below it, the environment changes dramatically. As you descend past 200 meters, sunlight begins to fade. Colors disappear one by one. Reds vanish first, then oranges and yellows. By the time you reach 1,000 meters, the world is pitch black. No blue water, no shimmering light, just darkness so complete that vision becomes almost meaningless. From this point on, life must survive without sunlight, relying on strategies that seem more like science fiction than biology. Pressure is the next thing most people underestimate. At sea level, you're under 1 atmosphere of pressure. For every 10 meters you go down, the pressure increases by another atmosphere. At 1,000 meters, that's 100 times the pressure at the surface. At the deepest parts of the ocean, the pressure is over 1,000 times greater. That's like having the weight of several jumbo jets pressing down on every square inch of your body. To a human, this pressure would be instantly fatal. Lungs would collapse. Bones would crack. Even submarines struggle to withstand these forces. Only a handful of specialized deep-sea vessels have ever made it to the deepest points, and each descent is a high-risk engineering challenge. Yet life thrives there. One of the most mind-bending facts about ocean depth is that the deeper you go, the stranger life becomes. In the absence of sunlight, photosynthesis is impossible. Instead, many organisms rely on marine snow, a constant drizzle of organic debris falling from the surface. Dead plankton, waste, decaying matter. It doesn't sound glamorous, but in the deep sea, this is a vital food source. Other creatures use chemical energy instead of solar energy. Near hydrothermal vents, cracks in the ocean floor that release superheated, mineral-rich water, entire ecosystems flourish. These vents can reach temperatures over 400 degrees Celsius, yet nearby animals survive because the extreme heat dissipates quickly in the surrounding cold water. Giant tube worms, clams, and bacteria form communities that have nothing to do with sunlight. Instead, bacteria convert chemicals like hydrogen sulfide into energy, forming the base of a food chain completely independent of the sun. This discovery fundamentally changed our understanding of life, proving that sunlight is not the only way ecosystems can exist. As you descend further, beyond 4,000 meters, you enter the abyssal zone. This region covers more than half of Earth's surface, yet it's one of the least explored environments on the planet. The temperature here hovers just above freezing. There are no seasons, no weather, no day or night cycles. Time feels almost suspended. Animals here often grow slowly and live long lives. Food is scarce, so efficiency is everything. Many species are soft-bodied, conserving energy. Others have enormous mouths and expandable stomachs, because in a place where meals are rare, you eat whenever you can, regardless of size. Bioluminescence becomes a common language in this darkness. Many deep-sea creatures produce their own light using chemical reactions in their bodies. Some use it to lure prey. Others use it to communicate, confuse predators, or even camouflage themselves by matching faint light from above. In a world without sunlight, light becomes one of the most powerful survival tools. Then there are the trenches. Ocean trenches are the deepest places on Earth, long, narrow depressions where tectonic plates collide. The deepest known point on the planet lies nearly 11,000 meters below the surface. That's almost 36,000 feet. To put that into perspective, commercial airplanes cruise at about 35,000 feet above the ground. The deepest part of the ocean is roughly as far below sea level as planes are above it. Reaching these depths is incredibly difficult. Only a few human-crewed missions have ever made it down, and they lasted only hours. Most exploration relies on robotic vehicles that can withstand the crushing pressure. Even then, the risks are enormous. Equipment failure at these depths often means permanent loss. Despite this, life has been found even in the deepest trenches. Tiny organisms, fish, and crustaceans survive in conditions once thought impossible. Their cells are specially adapted to extreme pressure, using unique proteins and membrane structures that prevent them from collapsing. Studying these organisms isn't just fascinating, it has real-world applications, from medicine to biotechnology. One of the most shocking insights about ocean depth is how little we've explored it. Humans have mapped the surfaces of the Moon and Mars in greater detail than the deep ocean floor. More than 80% of the ocean remains unexplored or poorly mapped. We know more about distant galaxies than we do about vast regions right here on Earth. Part of the reason is cost. Deep-sea exploration is expensive, dangerous, and technically demanding. Space exploration gets more attention, but in many ways, the deep ocean is just as hostile, if not more so. You can't send signals easily. You can't rely on sunlight. You can't escape pressure. The deep ocean also plays a massive role in regulating Earth's climate. Cold, deep waters store enormous amounts of carbon dioxide, acting as a long-term carbon sink. Ocean currents move heat around the planet, stabilizing temperatures and weather patterns. Without the deep ocean circulation system, Earth's climate would be wildly different, far less hospitable to human life. What happens in the depths doesn't stay in the depths. Changes to deep ocean chemistry, temperature, or circulation can take centuries to manifest at the surface, but when they do, the effects can be global. This makes the deep ocean both a buffer and a warning system for climate change. There's also a psychological aspect to ocean depth that humans rarely talk about. The deeper you go, the more isolated you become. Light disappears. Sound behaves differently. Distances feel distorted. Even experienced divers describe a sense of unease as depth increases, a primal awareness that you are entering an environment not meant for you. This fear isn't irrational. The deep ocean represents the ultimate unknown on our own planet. It's a place where our senses fail, our technology struggles, and our assumptions about life are constantly challenged. The deep sea is Earth's largest habitat. It holds countless species we haven't discovered yet, many of which may go extinct before we ever know they existed. Each expedition reveals new organisms, new behaviors, and new biological mechanisms that rewrite textbooks. Some deep-sea creatures can survive extreme radiation. Others produce natural antifreeze proteins. Some have enzymes that function under pressures that would destroy most known life. These adaptations aren't just curiosities. They offer insights into how life might exist on other planets and moons with subsurface oceans, expanding our understanding of what habitable really means. When you think about the ocean as just a big body of water, it's easy to underestimate it. But when you think of it as a vertical world, layered with increasing darkness, pressure, and mystery, it becomes something else entirely. A vast, alien frontier beneath our feet. The next time you stand at the shore, remember this. Beneath the waves lies a realm deeper than the tallest mountains are high, darker than the deepest night, and more unexplored than the surface of distant worlds. The ocean isn't just deep. It's a reminder of how much there is left to discover, not somewhere far away, but right here, on our own planet. And perhaps the most astonishing part of all is this. Despite all our technology, all our satellites, and all our scientific achievements, the deepest parts of the ocean remain largely untouched, silently waiting, holding secrets that could change how we understand life, Earth, and ourselves.